Hi everyone, welcome to another video. All right, so today we have this nice question about rotational motion, which is the motion executed by a body, rotating about its axis or frame of reference. All right, so now this is a very simple question, so to speak. But what we have here is more like for those who for those of us that we understand that we have some important equations when it comes to equation of motion. Okay, there are about four essential equations of motion, even though we have more than that. Okay, even though we have more than that, because we have more than four equations of motion. But I think these four equations are the most common. Like, we have the one for average distance, which measures average velocity, okay, multiplied by time. That's average distance. This is for uniform motion. Okay, that is for uniform motion. Okay, for uniform motion. So we know that average distance is equal to the product of average velocity multiplied by time. Now, then we also have the equation for velocity. Velocity, which is the final velocity, equals to the initial velocity plus the product of linear acceleration and time. That's another equation of motion. All right, then also we have this other equation, which is the equation for the distance traveled. Okay, this is average distance. So for distance traveled, it says ut, that is the product of the initial velocity and time, okay, plus 1/2 of acceleration, okay, multiplied by the square of what? Of t. Then the last equation, which is that's the fourth equation of motion, okay, is the v square equals to u square plus 2as. So this is for uniform motion. So when it comes to rotational motion, okay, now for rotational motion, okay, now these equations are equations that are, they are related. The only difference is in terms of the terminologies. Okay, now because we have rotational motion, so the velocity will be angular velocity. Okay, and then because it is also rotational motion, when we have angular acceleration, sometimes we can also call it rotational acceleration. So if I want to write, let's say I want to write the rotational formula for displacement, that's we have angular displacement, that's average. So that will be the initial angular velocity plus the final angular velocity over 2 multiplied by what? Time t. Now then for this one, we then have the final velocity, angular velocity, equals to the initial angular velocity. Then we also have the what? Rotational acceleration, also known as what? The angular acceleration multiplied by time. That will be the second equation. Then also we have the distance. So this will be angular displacement. Okay, the angular displacement will be the angular velocity multiplied by time, then plus 1/2 of angular acceleration multiplied by t squared. All right, that's time raised to the power of 2. Now also for angular velocity, now we have, this is final velocity, that's in the case of uniform motion. But in the case of rotational motion, so it will be w squared, which is angular speed squared. Then we also have the initial angular velocity plus 2 multiplied by angular acceleration, then multiplied by what? The angular displacement. So this is how we can show comparison between equation of uniform motion and that of rotational motion. Like I said, rotational motion is the motion executed or exhibited by a body, rotating about its axis or about what? About a frame of reference. All right, so now let's see how we can solve this very simple question. Now we have a flywheel originally at rest. Okay, now let's not waste time. So in this case, originally at rest, which means the initial angular velocity okay, that is the initial angular velocity will be what? Be equals to 0. You know, when a body is at rest, its velocity, that is its starting velocity or initial velocity, will be what? 0. So in this case, because the motion is rotational motion, so we then have the angular velocity to be what? 0. Okay. Now it's to reach an angular velocity of 36 rad per second. That's radian per second in 6 seconds. So which means the final angular speed will be 36 rad per second. Okay, then in time 6.0 seconds. So the time is 6.0 seconds. All right. So what constant angular acceleration must it have? So we can check the list we have here. Now, which one can we use, you know, to calculate the value of, you know, the angular acceleration? Okay, so to calculate the angular acceleration, so we're going to what? We're going to use this equation, that is angular speed equals to the initial angular speed plus the what? Angular acceleration multiplied by time. Don't forget, this is the final angular speed. Okay, so in this case, we're going to have final angular speed equals to the initial angular speed plus angular acceleration multiplied by time. So we have the value for t, we have the value for the final angular speed. Now we know that the value for the initial angular speed is what? 0. So here we want to calculate the what? The question reads, what constant angular acceleration must it have? So we are looking for the value of angular acceleration. So which means in this case, now let's plug in the value for W. So that will be 36 equals to 0 plus so then we have the angular acceleration multiplied by 6.0 multiplied by 6.0. So this will be 36 equals to 6 alpha. Then we can divide, okay, both sides by 6. So dividing both sides by 6, okay, so which means the angular acceleration will be 6 rad per second square. So this is the angular acceleration, because the question reads, what constant angular acceleration must it have? Okay, so that's it. All right, so now for the second question, okay, now we have, what total angle does it turn through in the 6.0 seconds? That is, what is the angular displacement? Okay, the angular displacement, that is what total angle does it turn through, okay, in 6.0 seconds? So which means we're going to make use of the formula for angular displacement. So we have the angular displacement, which is what we're looking for. That's the total distance, total angular displacement, or total distance covered. Okay, all right. So in this case, so the angular displacement is what we have as the angular velocity, initial angular velocity multiplied by time plus 1/2 of angular acceleration multiplied by t squared. Now we know the value for angular velocity, initial angular velocity is what? 0. Okay, now then we also know that the value of time t is what? 6 seconds. The value of time t is 6 seconds. Okay, then we also have the value of the angular acceleration to be 6 rad per square seconds. All right, so we then have this will be the total angle it turns through, okay, to be equals to, this will be 0 plus 1/2 multiplied by 6, then multiplied by 6 squared. Okay, so this will be equals to, now 6 divided by 2, that will be 3. So we have 3 multiplied by 36. 3 multiplied by 36. So this will be the total angular speed would be, now this will be 108. So this will be 108 rad. That is 108 rad. So that is the total angle it turns through in 6 seconds. The noblest pleasure is the joy of understanding. Bye bye.